Welcome, everyone, to this deep dive into Azure Storage Services. This is number 9, episode 9 in our Mastering Microsoft Azure Fundamentals series.
Ninth already, wow.
I know, right? And we've got a whole heap of information you sent over. Our goal today really is to cut through it all and give you the essentials on how Azure actually handles storing your data up there in the cloud.
Yeah, absolutely. It's fundamental, really. Azure Storage pops up almost everywhere in the platform. So we definitely need to break down the different ways they let you store data.
Exactly. So let's kick things off with the different types of Azure Storage accounts, because it's not just one thing, is it?
No, not at all.
The type you pick really impacts what services you can use and, importantly, how your data is protected. It's kind of like choosing the right box before you decide what to put in it.
That's a perfect analogy.
Yeah.
And you'll see these account types are really tailored. The standard general purpose V2 account, that's your workhorse.
Right.
It handles pretty much everything. Blobs, files, queues, tables, even the newer data lake storage Gen 2. Then you get into the premium stuff, like premium blobs for high transaction stuff, or premium file shares if you need, say, NFS support with Azure Files.
NFS, okay.
And premium page blobs. Those are really just for the high-speed disks that your virtual machines use.
So it's really about matching the account to what you need performance-wise, access-wise, and like you said right away, you also have to think about redundancy. LRS, GRS, ZRS, all those acronyms.
Yep, they hit you early.
But you have to understand them, right? Because it's about resilience and, well, cost too.
Definitely. And even before you put data in, you need to know about the endpoints and the names. How do you actually address the storage?
The address in the cloud. Good point.
Yeah, every storage account needs a name that's unique across all of Azure. Global uniqueness.
Right. Lowercase letters and numbers, 3 to 24 characters, I think.
That's the one. And that unique name becomes part of your web address, your endpoint, for each service.
Like if I call my account mycoolsite, the blob endpoint would be something like https.mycoolsite.blob.core.windows.net.
Exactly. And then you'd see .avester for data lake, .file for files, .queue, .table, or stuff. You get the idea. It's systematic.
And that unique name ties into the whole global DNS system for Azure, doesn't it?
That's a really key point, yeah. So, okay, let's dive into the core protection mechanism. Azure Storage Redundancy. You mentioned the acronym.
Yeah, alphabet soup, yeah.
Yeah. Let's try and clear that up. The basic idea is super simple. Make lots of copies.
Always a good plan with data.
Right. So within the main Azure region where you create your account, Azure automatically makes at least 3 copies. Your first choice is how it makes those first 3 copies.
And that's where locally redundant storage, LRS, and zone redundant storage, ZRS, come in.
Precisely.
Yeah.
LRS is the most basic and usually the cheapest. It keeps 3 copies, but they're all inside one single data center building.
Okay. So that's great for like a disk failing or a server rack going down.
Absolutely. You get amazing durability against that kind of hardware failure that you talk about, 11.9s of durability.
11.9s? Wow.
But, and here's the catch, if something bigger happens that affects that whole building, like a major fire or a long power outage,
then all your copies could be unavailable. Makes sense.
Exactly. So that's where ZRS, Zone Redundant Storage, comes in. This uses Azure's availability zones.
Which are like separate, independent physical locations, but still within the same overall region, right?
That's it.
Yeah.
Think separate buildings, maybe separate power, cooling, networking. With ZRS, Azure writes your data synchronously across 3 of these zones.
Synchronously is the key word there, isn't it?
It really is. When you write data, the operation doesn't confirm success until it's safely stored in all 3 zones. So even if one entire zone goes offline.
Your data is still there and you can still read and write to it from the other zones.
Correct. And your durability jumps to 12 nines. Microsoft often pushes ZRS for anything needing high availability, or if you have rules about data staying within a specific geographic border.
Okay, so LRS for basic, ZRS for high availability within a region. But what about, really big disasters, like something affecting the whole region?
Good question. That's where the next level comes in. Replicating your data to a completely separate secondary Azure region, usually hundreds of miles away.
Your disaster recovery plan, essentially.
Exactly. And here you've got, again, a couple of main options. Geo-redundant storage, or GRS, and Geozone Redundant Storage, or GZRS.
More acronyms. Okay, break them down.
Okay, GRS, think of it as taking your LRS, set up those 3 copies in one data center in your primary region, and then asynchronously copying that data to another single data center in that paired secondary region.
So 3 copies in building A in region 1 and 3 copies in building B in region 2.
Basically, yeah. And this gets you up to wait for it, 16 nines of durability.
16. That's just astronomical. Seriously hard to even comprehend losing data.
It is. It's designed for extreme durability. Now, GZRS, as the name kind of suggests, combines ZRS in the primary with geo-replication.
Ah, okay. So you get the synchronous replication across availability zones in your main region.
Right, for that high availability.
And then it also copies that data asynchronously using LRS over to the secondary region.
You got it. So ZRS protection in the primary plus LRS protection in the secondary. It's kind of the belt and suspenders approach. Offers the highest levels of consistency, durability, and availability. Really for your absolute top-tier mission-critical stuff.
Makes sense. Now, you mentioned asynchronously for both GRS and GZRS when copying to the second region. What does that mean practically?
Good catch. It means there's a small delay. When you write data in the primary region, it takes a little bit of time for that change to get copied over to the secondary region.
So if the primary region just vanished suddenly,
There's a chance that the very latest data, written just before the disaster, might not have made it across to the secondary yet.
is there a way to know how much data you might lose?
Yes, that potential data loss window is called the Recovery Point Objective, or RPO. Azure typically aims for an RPO of less than 15 minutes for GRS and GZRS.
Okay, less than 15 minutes.
But, and this is important, that 15 minutes isn't a guaranteed service level agreement, an SLA. It's a target. Usually it's much lower, but it could be longer.
Right. So there's a trade-off there. You get incredible durability against region failure, but there's that small potential RPO window. And normally you can't actually read the data in that secondary region unless Azure officially fails over, can you?
That's the default, yes. The secondary copy is just sitting there waiting for a disaster declaration and failover from Microsoft.
Well, what if you want to read from it? Maybe to, I don't know, spread out read traffic or just have access if the primary is having a temporary glitch?
There are options for that too. You can choose Read Access Geo-Redundant Storage, RAGRS, or Read Access Geo-Zone Redundant Storage, RAGZRS.
Catchy names.
Yeah. These basically give you an extra read-only endpoint that points to your secondary region's data.
Okay, so you can actively read from the secondary copy anytime.
Yeah. Exactly. Super useful for distributing reads globally or just as a fallback reading source. But you always have to remember that the data you're reading there might be slightly stale because of that asynchronous replication lag we talked about.
Right, the RPO factor again. Okay, I think that clears up the account types and especially the redundancy options. That's a complex but crucial piece.
Yeah.
So once you've picked your account and your redundancy level, what can you actually store? What are the main storage services?
Okay, yeah, the services themselves. Azure Storage offers a pretty versatile toolkit. We're mainly talking about Azure Blobs, Azure Files, Azure Queues, Azure Disks, and Azure Tables. 5 main ones.
Got it. Let's start with blobs. That sounds like just stuff, right?
Pretty much. Blob stands for a binary large object. It's Azure's massively scalable object storage. Think unstructured data documents, pictures, videos, backups, log files, you name it.
Okay. And isn't this also where Data Lake Storage Gen 2 fits in?
Exactly. Data Lake Storage Gen 2 is built on Blob storage, but adds features like hierarchical namespaces and specific optimizations that make it really good for big data analytics workloads.
Right. And blobs have those different tiers, don't they, for cost saving?
Yes, that's a really important feature. To help manage costs, you can place your Blob data into different access tiers: hot, cool, cold, and archive.
Hot for stuff you access all the time.
Yep. Cool for less frequent access, maybe data older than 30 days. Cold for even less frequent, think longer-term backups maybe. Access maybe once or twice a year. And then archive is for data you barely ever touch, like for long-term compliance holds. It's the cheapest to store, but slower and costs more to retrieve.
So you need to understand how often you'll need the data to pick the right tier and save money.
Precisely. Managing that data lifecycle is key to optimizing Blob storage costs.
Okay, makes sense. What about Azure Files then?
Azure Files gives you fully managed file shares in the cloud. The key thing here is they speak standard file protocols, SMB, which Windows uses heavily, and NFS, common in Linux and macOS environments.
Ah, so you can just map a drive to it like a regular network share.
Exactly. From your machines in Azure or even from your on-premises computers. This makes it fantastic for lift and shift migrations, moving existing applications that rely on file shares without having to rewrite them.
Yeah, I can see that being super useful. No need to manage file server VMs yourself.
That's the beauty. Then you have Azure Queues. This is different. It's a messaging service.
Like sending messages between different parts of an application.
Exactly. It lets components communicate asynchronously. One part drops a message in the queue, another part picks it up and processes it whenever it's ready. Great for decoupling parts of an application, making it more resilient. Think microservices.
Right, so if one part is busy or down, the messages just wait in the queue. Improves stability. Got it.
Next up, Azure Disks.
Azure Disks are your bread and butter block storage for Azure virtual machines. They act just like the hard drives, the SSDs, attached to your VMs, providing that persistent storage they need to run the OS and applications.
Okay, so the virtual hard disks for your VMs. Simple enough. Yep. High performance, high availability options there too. And finally, Azure Tables.
Tables. Like database tables.
Sort of, but it's no SQL. It's for storing large amounts of structured but non-relational data. Some key value pairs, but with a schema-less design. Very flexible, very scalable for certain types of applications, maybe like user profiles or device telemetry.
Okay, no SQL tables, so quite a range.
Yep.
Object storage, file shares, messaging queues, VM disks, and NoSQL tables. Covers a lot of ground.
It really does.
Now, if someone's just starting out, it might feel a bit daunting. What's a good, simple first step to just try something?
Yeah, the Azure portal makes it pretty easy. A really common first step is just creating a blob container. You create your storage account first, then within that you create a container, like a folder, basically to organize your blobs.
Okay, create account, create container. Seems manageable.
And when you create that container, you can even set its access policy, like allowing anonymous public read access if you need to host things like website images or documents publicly.
Ah, okay. Good to know. So that's a hands-on start. But what about the other end of the scale? What if I have like terabytes or petabytes of data sitting on premises that I need to get into Azure? Uploading that sounds painful.
It can be, yeah, over a standard internet connection. For those big moves, Azure has specific tools and services. The two main ones are Azure Migrate and Azure Data Box.
Azure Migrate. That sounds like it's for moving whole systems.
Exactly. It's more of a centralized hub or platform for discovering, assessing, and migrating your on-premises stuff. VMware VMs, Hyper-V VMs, physical servers, databases, web apps over to Azure. It gives you tools to plan and execute the move.
So it helps you figure out if things are compatible and orchestrates the actual transfer?
Yeah, it's got tools like the Data Migration Assistant for SQL databases, App Service Migration Assistant for web apps.
Yeah.
It's pretty comprehensive for those broader migration projects.
Okay. And Azure Data Box. That sounds more like shipping data.
It is. For really huge data sets where network transfer just isn't practical, maybe it would take weeks or months, Microsoft will literally ship you a rugged, secure, physical storage device.
Like a big hard drive.
A very big secure box, yeah. Capacity is up to around 80 terabytes for the standard data box device. You connect it to your network, copy your data onto it using standard tools like SMB.
Then ship it back to Microsoft.
Yep. You ship it back, they connect it in their data center, and upload your data directly into your Azure Storage account. Much faster for those massive initial transfers.
Wow. Okay, that makes sense for truly enormous amounts of data. Secure, too, I assume.
Oh, yeah, very secure. The data is encrypted, the devices are tamper-resistant, and they securely wipe the disks after the upload. They also have smaller versions like DataBox Disk, and even options for exporting data out of Azure if needed.
Okay, so Migrate for whole environments, Databox for bulk data shipping. What about just day-to-day management, moving files around, uploading new stuff once you're set up?
Yeah, for the more routine tasks, there are some great tools. AzCopy, Azure Storage Explorer, and Azure File Sync are probably the main ones.
AzCopy. That sounds like a command line thing.
It is. It's a really powerful and efficient command line utility. Great for scripting and automation. You can use it to upload, download, copy files between accounts, even synchronize directories. Super fast, very reliable.
Okay, for the automation fans, what about as GUI, folks?
That's where Azure Storage Explorer comes in. It's a free graphical application for Windows, macOS, and Linux.
Ah, nice.
It gives you that familiar visual interface to browse your storage accounts, containers, file shares, upload and download files just by dragging and dropping, manage permissions. It's really useful.
And does it use AzCopy underneath?
Often, yeah.
Yeah.
It leverages AzCopy for a lot of the heavy lifting data transfers, giving you that GUI convenience on top of AzCopy's performance.
Cool. And the last one you mentioned was Azure File Sync. How's it different?
Azure File Sync is interesting. It's designed to bridge your on-premises Windows file servers with Azure Files. It essentially lets you centralize your file shares in Azure Files.
Okay.
But it keeps a cache of the most frequently accessed files locally on your existing Windows server. so your users still get fast local access performance.
Ah, so it's like extending your local file server into the cloud, keeping hot files local, and maybe less used ones just in Azure.
Exactly. It has a feature called cloud tiering that does just that. It automatically archives cooler files to Azure files, freeing up space on your local server, but keeping them seamlessly accessible if needed. Best of both worlds, really.
Okay, that sounds quite powerful for hybrid setups. So AzCopy for command line speed, Storage Explorer for visual management, and File Sync for integrating on-prem servers with Azure files.
That's a good summary. Different tools for different jobs.
Wow. Okay, well, this has been genuinely really insightful. We've covered a lot of ground, from picking the right storage account type, digging into those really important redundancy options, LRS, LRS, GRS, GZRS.
And those durability numbers.
Yeah, the 11, 12, even 16 nines. It's incredible.
Yeah.
And then exploring the actual services, blobs, files, queues, disks, tables, and finally, how to actually get data in there and manage it with Migrate, Data Box, AzCopy, Storage Explorer, and File Sync.
I think the key takeaway is just how much flexibility and control Azure gives you. You really can and should tailor the storage to fit exactly what you need, technically and financially.
Absolutely. We mentioned creating a blob container as a good first step in the portal.
Yeah, definitely worth trying. And remembering those migration tools like Migrate and Data Box for the big stuff, and the others like AzCopy and Storage Explorer for everyday use.
And that constant balance, right, between the cost of these options and the level of availability and durability your application actually requires, those nines aren't free.
They certainly aren't, but they represent a serious commitment from Azure to keeping your data safe.
Definitely. So just as a reminder for everyone listening, if you want to go even deeper into all these Azure fundamentals, our book, Mastering Microsoft Azure Fundamentals, AZ900 Exam Prep, is out there on Amazon. Check the description for a link.
It covers all this and more, yeah.
And looking ahead, our next deep dive, we're shifting gears slightly, but staying on a critical path. We'll be tackling Azure Identity, Access, and Security.
Which ties directly back to this, right, now that you know how to store your data.
How do you protect who can access it? Exactly. It builds right on top.
So maybe a final thought to leave people with.
Yeah.
Considering all these storage options, the tiers, the redundancy levels we talked about, how would you go about designing a storage solution for, say, an application that has really spiky, unpredictable access patterns, but also handles data where integrity is absolutely paramount?
Ooh, that's a good one. Balancing performance, cost, durability, availability.
Exactly. It really makes you think about the power and the choices you have with Azure Storage. Hopefully this discussion gave everyone a solid foundation to start thinking about those kinds of possibilities.